I don't know what we're going to do here. We have to start off, we have to multiply these three big numbers and get an enormous number, and then we have to figure out what number we cube to get that enormous number. So it's bad enough we have to multiply these three giant numbers, but then we have to cube a bunch of numbers and try to hit that enormous product we got before. That'll take forever. We have to do something different. Now when I see a product of integers, one thing I like to think about is prime factorization. So I think of the primes as building blocks of the integers. It's just one group of primes you can multiply together to get 360. That's the prime factorization of 360. And same thing for 200 and for 81. So I'm going to start this problem just by finding the prime factorizations of these three numbers. Now I don't know for sure that getting the prime factorizations is going to help me solve the problem, but sitting here and staring at the problem isn't going to help either. So rather than sit and stare, I'm going to do something and hope it turns out to be something smart. So we'll start with 360. We're going to find the prime factorization of that. That's just 10 times 36. Let's see, 10 is 2 times 5. 36 is 4 times 9. 4 is 2 squared. 9 is 3 squared. And now I can combine the 2 and the 2 squared. That gives me 2 cubed. I have the 3 squared. And I have the 5. So there's my prime factorization of 360. We'll go ahead and write that down back here and hope it proves to eventually be useful. That gives us 2 cubed times 3 squared times 5. All right, 200. Let's do 200 next. 200. Well, 200 is just 2 times 100. And 100, well, that's 10 squared, so it's 2 squared times 5 squared. 2 squared times 5 squared. And that gives me a prime factorization of 2 cubed times 5 squared. I'm going to check that real quick. I like to check my intermediate steps just to make sure I don't mess up. 2 cubed is 8. 5 squared is 25. 8 times 25, that's 200. We have the right prime factorization there. So this is just 2 cubed times 5 squared. And 81. 81 is just 9 times 9. 9 is 3 squared. 3 squared times 3 squared. That is 3 to the 4th. All right, let's see. So now I can combine a bunch of these. I can combine 2 cubed and 2 cubed. That gives me 2 to the 6th. 3 squared and 3 to the 4th. That gives me 3 to the 6th. 5 and 5 squared. That 5, of course, is 5 to the 1st. So we have 5 cubed. Well, that looks a little simpler than this, maybe. I mean, if all the exponents were 3, we'd feel really close because we're looking for the cube of an integer. We have those 6's sitting there. I can write 6 as 2 times 3. Let's check that out. Right, each of these exponents of 6 is 2 times 3, because in the end we want a cube. We want a cube of an integer. And now we can use one of our exponent rules. We can write this as the cube of an integer. We can write this as the cube of 2 squared. And it's just our power of a power rule. 2 squared raised to the 3rd. We just multiply the exponents 2 times 3. Go in the other direction here. We do the same thing with the 3. And now we have a product of cubes. Same exponent. We know how to multiply powers that have the same exponent. We have another exponent rule for that. If we have a product of cubes, well, that's just the cube of the product of the numbers. We have the cube of an integer. All we have to do is compute this integer. 2 squared is 4. 4 times 5, that's 20. 3 squared is 9. 9 times 20, that's 180. And we are done.